Okay, awesome. Well, it's really great to be here with you guys today. It's Friday morning for me, Friday afternoon for you. So at least you are all closer to the weekend, closer to finishing out your week. I still got a few more hours to go, so I just got to get through this Friday. But yeah, I appreciate the intro, and I really enjoy presenting for user groups and doing actual SolidWorks presentations. I'll share my screen here and we'll get started and we can talk through kind of what we're going to cover today. I really enjoy doing this sort of stuff because in my current role here at SolidWorks, I work here at SolidWorks and I've been here for about 5 years. I'm coming up right on 5 years. But in my previous role, I managed tech support and I worked with SolidWorks every day for about 13 years. So I'll jump right to my kind of like intro slide here. I went to engineering school. I spent about 12 plus about 13 years in the SolidWorks reseller industry using SolidWorks, doing SolidWorks tech support. I'm a CSWE. I had thousands of support cases and hundreds of SolidWorks classes taught to people around the US. And I was a technical support manager since about 2013, regularly presented at my local user group and at SolidWorks World. And outside of SolidWorks, I also specialized in SolidWorks Composer, SolidWorks Inspection, and SolidWorks PDM. And that's the other thing with SolidWorks too is it's a huge world of a lot of different products and a lot of different disciplines, right? So yes, you can get really great at CAD modeling and designing parts, but then, what about technical documentation? What about simulation? What about managing all of that data in a PDM system, in a data management system? So there's almost, you'll never, this is a big statement, but you'll never learn it all because there is so much of it. So you also kind of have to pick your path and pick what you're going to focus in. And for me, again, I got to focus in SolidWorks for sure, but then these other three products as well: Composer, Inspection, and PDM. So they were a lot of fun. So this presentation today is all about my tips and tricks from doing 13 years of tech support and some of the stuff that I came across all the time. But also, like, I don't work in tech support anymore, right? I don't tell anybody this, but I barely use SolidWorks anymore because my job is not the same, right? So if you come across technical support issues, if you come across something interesting in SolidWorks, send it to me. I'd love to see it. And I'd love to actually add it to this presentation in the future because I'm not doing tech support every day anymore. And I don't have that direct path or that direct connection to what's going on in tech support. So keep me posted, keep me in mind if you come across anything. But what we're going to do is kind of get into like a question and answer format here in SolidWorks. And I actually have SolidWorks open in the background. So we're going to do everything live. I'm not showing you any videos or any pre-record stuff. We'll click through and do everything live in SolidWorks. But this was a question, if I'm getting into details from tech support, right? This was a question that came into tech support kind of frequently. And at the time, it was, how do we create a standard route that we can use again and again and revision manage it in PDM? How do we use it in PDM? So the answer to that was doing something called reuse route. But the question's kind of bigger than that, right? Because if you're familiar with SolidWorks, I'm going to jump over to SolidWorks now. If you're familiar with SolidWorks, you have parts and you put parts together into assemblies, right? That's basically at the end of the day what you do with SolidWorks. And if you get really advanced or get really technical or detailed, you can do assemblies like this, where you have a detailed wire route showing, how a component is wired from one end to the other. And that's really powerful because you can get the lengths of those wires. You can figure out the covering, figure out how big they are, and place clips. So that really helps you lay out your assembly. This is just like an old electronics enclosure demo set that we used to use way back when. But you don't want to do all that manually, right? Like no one wants to manually. How would you? Maybe this is a good question for everybody, right? Like how would you model a wire if you had to do it manually, if you had to do it by hand? You can say it here out loud, or you can drop it in the chat. Like what's the feature you would use if you wanted to? Yeah, exactly. Faiz says I would use sweep. Exactly, right? You don't want to sweep little circles all over this assembly manually. So SolidWorks created something called routing. And routing is an add-in that you can use in SolidWorks, and routing gets you electrical, piping, and tubing routing. So those are all design realms or design types that really work well with routing. And when you have routing turned on, you also get this little extra library in your design library. So it actually is a routing folder, and then you have electrical, piping, tubing components. And a route component is just like any other SolidWorks file, right? It's really just a SolidWorks file, but the component gets a little bit of extra information in it. And the reason for that is, like, if I want to start a new route here, right, I can find this RJ45 connector, which this is just an Ethernet connector, right? You've seen one of these for sure. And if I click and drag that into the assembly, it actually snaps right into place, which is really cool. You can see it kind of snapping into these two RJ45 ports. And as soon as I let go, it automatically starts a new route and it brings up the route properties for that route. The reason for that is that little part had some routing information built into it. It had a little bit of routing info in the part file itself. So routing knows that when you drag and drop one of those in, it automatically starts a route. So here I can decide what templates I'm going to use. I can decide what this is. It is a harness, and I can even decide what's the outer diameter, the total outer diameter of this wire. So you can mess around with that if you're making a bigger or smaller wire. But I'm going to hit green check just to confirm those route properties. And it's now put me directly into this new route to continue modeling here, to continue working. So let's bring another one in. I'm going to go back to my library. I'm going to go back to that RJ45 connector, and then we'll drop it like into this port here, for example. Oh no, SolidWorks is crashing. You guys can't see it, but on my other screen, SolidWorks just crashed. Man, this is live. This is what we do, right? All right, so here's a new tip. When SolidWorks crashes, what do? Right? You certainly restart SolidWorks, but also I recommend this quite a bit. We'll actually talk about this a little bit later, is SolidWorks RX. So we'll pull this up a little bit later in this presentation of what RX does. But if you've never opened SolidWorks RX, it's pretty cool. It has a lot of really great built-in diagnostics, including information about your graphics card, information about your RAM, your total memory, all that stuff. We'll cover this a little bit later, but I would always advise you to open that when you're ready. So, all right, so we're doing this live, everybody. You gotta love live demos. But when you're also in a live demo and SolidWorks crashes, I go back to 3D Experience SolidWorks Premium, and then I launch it. Notice I'm launching it here from the 3D Experience platform. It's not launching from my desktop. I'm opening the SolidWorks connected version, which is SolidWorks, right? It still is SolidWorks, but it launches from that platform and it actually connects right to our cloud space. All right, we're back in business here. So let's do another R for recent documents. I should have that screen in the background here. Is it hiding? Let's see. All right, we're working again. Cool, close that. It is this guy. All right, so let's just do that and that sensor one more time. Let's suppress all missing components, and then we'll replace that component too. Routing is still turned on. My route got deleted. Man, I put so much time and work into that route. We're gonna have to do it all over again. Let's see if it crashes again. That's always fun to like do something over again. And if you get a repeatable crashing, see if it crashes again. So we'll do design library, routing parts, electrical, RJ45, and we'll click and drag that in. Looks good. Let's bring another one in, another RJ45, and I'll drop it here. Oh, I gotta complete this command. Another RJ45. We'll drop it there. All right, SolidWorks didn't crash. We're good. We're back. We're back in business. All right, so this is pretty cool, right? So now that you're routing and you have your two parts in space, I have this one here and this one over here. As I think Fai said before, we would use sweep, right? If you're doing that manually, but if you're in routing, you have something called auto route. And auto route lets you pick, I want to route from this point to this point, and it automatically sketches the path and says, hey, this is what the sweep is going to look like. That looks pretty good. And I can green check that. And I can actually exit out of the route to see what that looks like. And I could increase that wire diameter, by the way. We just kind of made a small wire. But if you look at what that did, is it inserts the part, and then it makes a nice straight section. You get a little stub here. And then it automatically sketches this 3D sketch and the sweep for you from one part to the other one. That saves you a ton of time, right? That means that when you're working in an assembly, all you have to do is drag and drop your parts in and then auto route from one part to the other. Now, to kind of finish this question, the customer or the tech support question was always like, hey, that's great, but if I'm doing that over and over again, I don't want to have to repeat that process. Maybe you use the same wire all the time, right? Maybe you have an assembly where you have a typical wire assembly, right? Or a typical wire harness where it's the same one you use over and over. SolidWorks has this command called reuse route. And reuse route lets you kind of toggle through, like, okay, here's one route I could reuse. Here's another route I could reuse. Here's another one. It's just kind of toggling through all the routes, or here's the one that we just made. So I want to reuse this one that looks pretty good. So if I kind of just drop it here in space, it starts putting you in the mode to place your connectors. So I know I want one connector there. And then I think I missed that one a little bit. And then one connector here. Oh, this one got misplaced, but and then it'll drop that one and I'll hit green check. Yeah, I missed this first one here, but let's do that one more time. I'm going to delete that route. Oh, I got to get out of the subassembly. Yes. All right, one more time. So we're going to do reuse route. I clicked a little too fast when I dropped that first component. So drop this one. As long as it snaps into place, this looks pretty good here. There we go. That guy, this is kind of cool too. Like, I don't even have to spin the assembly around to get it into this one. You can if you spin around a little bit just to make sure, but it will do a pretty good job of doing that, even if you do it by hand. Yes, that's fine. Looks good. Those connections are a little off. All right, there we go. It came up a little goofy with these route points here, but the point is I can click and drag and drop those routes in multiple times. That second one is kind of fighting me a little bit, but that's all right. And if you look at what routing does and what routing is, like I'll kind of zoom in on the tree here a little bit on this route. I'll zoom in a little bit. Everybody here is probably familiar with what a part is, right? You have a typical part file. This is your part symbol here. And routing is still doing that. It just puts it into a folder, right? It's still making parts. Like, here's my two RJ45 connectors, and then there's the cable itself that routes between them, and then the mates that hold them together, and then the route information. So it's still all the same stuff that you're familiar with, right? It's still just parts and assemblies. But what routing does is it automates all those clicks for you and just makes that process a lot faster. Hopefully, I ran into a couple problems there, but I think that's just from my my route template. So let's go all the way back to our presentation here, and that's a little demo of routing and a little demo of reuse route. And I even did a video about this a long time ago when I was working for the reseller, and I kind of link it here. And that video has 18,000 views at this point. So I guess people are pretty interested in routing. But if you did want a little bit of a deeper dive into that, I'll share this video here in the chat. We'll copy that out. And I'll drop this in the chat too. You can check that out anytime. But kind of a similar demo, but walking through that in a little bit more detail. All right, cool. Any questions in the chat? Let me know. When I first saw routing, I thought they would also show the current follow through. Please share some tips and tricks on weldments and surface modeling. I don't know if I have any weldments or surface modeling in this presentation, but we could also do that in a future one. This is pretty interesting too. So when you work in SolidWorks quite often, one thing you will definitely run into is references, is basically how parts are connected to each other. And again, getting back to, what's important in SolidWorks and what are some of the things you can do to keep working and not get bogged down by kind of daily tasks. I'm just going to open up like any old sample file here. It really doesn't matter what part we're going to use here, even if I use like this really simple sheet metal part. And if I take this sheet metal part, right, and I do File, Make Drawing from Part, and we'll just do a landscape drawing. And maybe you've done this before, right? Where you're making a drawing of a part, and that drawing will have a isometric view. The drawing will have a top view and a front view, and then we could project even off of that as well, like a bottom view or a whatever type view you want, right? The point is, as I'm doing that, now I go to File, Find References. I'm building in references to that original part. This was the original part that I opened, right? This cuts on bends part. But then I went and made this drawing. I haven't saved it yet, so it hasn't got a file name yet. But you're connecting parts. You're connecting parts and their references to their connections to each other. Even if I went back to that other assembly, a sensor enclosure assembly, this has 200 plus parts in it, right? A lot more parts. And I do File, same thing. Anybody can do this on your assemblies. File, Find References. Here's all of those parts that are in this assembly. So as a SolidWorks user, it's really important to keep track of your references and understand where they are, because SolidWorks is just looking for file names, right? So if you don't organize your files correctly, your assembly can actually open up the wrong file. It will open up, maybe there's another part named switch route, in that folder. Let's say you have another part in the same folder called switch route. Well, it's just going to open up that file, right? It's looking for a file named switch route in this example. And it's important as a SolidWorks user to check these references and make sure that, hey, my assembly or my drawing is referencing the correct parts and assemblies. Well, one thing that can happen, and this is what I was kind of showing before, right, is if I have a brand new drawing, so I say File, I'm just going to hit New, and maybe you've done this before where you just do a File, New Part, New Assembly, or a new drawing. This is a totally blank drawing. I'll just do like a landscape drawing here. This is a totally blank drawing. I haven't put any files on this yet, right? So if I do File, Find References right now, it's empty. There's nothing here. I haven't yet connected this drawing to anything else. If I simply go to, I'm going to close the model view. If I simply go to the View palette, which is where we were before, the View palette lets you pick, maybe I'll do this cuts on bends part. And even if I just hit cancel here, right? I'm going to hit cancel. I still haven't done anything. I still haven't brought any parts on here. But now if I go to File, Find References, I've created a connection to that cuts on bends part simply by opening the View palette. So the question all the way back here on the drawing or on the PowerPoint was, hey, when I open up a drawing, it has a weird reference. It's getting a weird reference to some part that it shouldn't be referencing. And that's important in SolidWorks, again, is tracking your references and making sure that they're connecting to the correct parts. So if you ever run into that, if you ever have a drawing or have a drawing that you open and it seems like it's pulling in the wrong reference, you'll know this. Like, has anybody ever used pack and go before? Pack and go is another really powerful command in SolidWorks. Like, pack and go is, if I switch back to this main assembly, if I want to send this assembly to somebody, a really easy way to do it is file, pack and go. Pack and go literally packs everything up and puts it into one file, right? That's what this little interface is. And you have a lot of options here. I could spend 20 minutes just on pack and go on these tips and tricks here. But the point is, in pack and go, sometimes you'll come across a reference where you go like, oh, that's weird. Why is pack and go trying to grab this like random file? And I'm just making something up here, but pack and go grabbing a random file and trying to bring it in. Well, a lot of times, getting all the way back to this drawing we were looking at a second ago, you have to open up this view palette. And even if I just go ahead and hit clear all, I can clear out that palette. Now that file find reference is gone. You're kind of wiping out that extra reference or that extra connection at that point. So maybe you've run into that before, but I highly suggest for any SolidWorks user that if you're working with an assembly, if you're working with drawings, keep a close eye on your references, right? Make sure that you're managing your files correctly. Regularly check your references and make sure that it's picking the right files to pull in. Okay, just checking the chat here. Part model assembly tips for mechanical components. Also questions about certificates. Okay. All right, so let's get to the next one here. This is a mechanical component. This is kind of a cool one. So in SolidWorks, sometimes instead of thinking about the part you're modeling, you should think about the result of the part you're modeling, if that makes sense. So the question was, I'm having trouble creating one smooth face for an up to face end condition. And what does that mean? So let's get over to SolidWorks. I'm going to just clear everything out right now. So I'll do window close all. That will get rid of everything I have, and then I don't need to save anything. And I'm going to hit R for recent documents. I use that all the time. Hitting R, recent documents, opens up this window here. And I'm going to open up this sweep part. Now, this is really simple so far, right? This is a really simple part. It has 3 things in the tree. It has a sweep, it has a plane, and then it has a boss extrude that goes up to that sweep. So the question from this customer, this is not their file, right? I had to recreate it with just kind of a sample file. But the question from the customer was, I'm trying to sweep something, like picture a really complex surface. And then they were extruding up to that surface. And I'll hover over this part and press tab. Tab hides a part, or excuse me, a body. Shift tab will bring it back. So if I just hover over this part and hit tab, it'll hide it and go away. But the problem is when they're doing the extrude, they get left with extra faces, right? It's not one smooth face. There's extra tangent faces here that are really just the result. I'll do shift tab to bring that back. They're really just the result of this, right? This part has one face there, and then one face there. So if we go back and look at that sweep, I'm just going to, in the tree, find the sketches that made that sweep. We talked about sweeps a moment ago when we were talking about routing. And I picked this sketch and I hit edit sketch. I can see what I did here is we sketched a kind of a simple shape with some tangencies. And those tangencies ended up making, I'll exit the sketch, ended up making perfectly tangent faces, which is fine, right? That's great. But when we go and extrude up to that face, our resultant body ends up getting those faces on it too, right? You end up with those same edges that were on the part you're extruding up to. Well, one really cool thing in the sweep command is a simple checkbox to fix this. So I can go back to sweep and I'll edit the feature for the sweep. And there's an option in the sweep itself called merge tangent faces. So if I merge those tangent faces, you see what's happening there is anywhere where there's a tangency in the sketch, it's merging that into one smooth continuous face. So I'll hit green check. That looks good. Let's bring that body back for just a second. And now you see a nice one single continuous smooth face on that bottom part. And then we'll hide our sweep. And then that means the resultant body, because this body here is just a simple extrude up to next, right? This is extruding up to the next surface in space. So when it extrudes up to next, you get a really nice continuously smooth face. Although I know that sketch actually had multiple edges, multiple faces in it. This is a simple example, but the point is pay attention to those options and pay attention to kind of your resultant face or your resultant body if you're doing any sort of end conditions like that. All righty. All right, so let's dig into some performance tips. This is stuff that's gonna, how do I make SolidWorks run faster? Let me know in the chat. Has anybody ever had SolidWorks run slow or crash? Has SolidWorks ever crashed? It just crashed for me 2 minutes ago. So let me know in the chat. Has anybody ever seen a crash before in SolidWorks? Well, there's a bunch of things you can do to make SolidWorks more stable and run better. There's a bunch of, in general, performance tips and in general things you can do that should help your experience improve in SolidWorks quite a bit. I'm going to pull up, we'll pull up SolidWorks actually to cover like one or two of these examples here. So, there's things in SolidWorks that you can kind of do regularly to check your performance. One of those things is the registry in SolidWorks. The registry is actually in Windows, and it's what kind of handles all your settings and handles all of your preferences, right? Any setting or anything you do in SolidWorks. So I'll go to SolidWorks and we'll do tools, options, document properties, and all your settings, right? Anything you do in system options or document properties, those are system options are all things that are stored in your registry. Well, sometimes your registry can get corrupt. Sometimes you run into some problems there, so you have to reset the registry. And maybe you've seen that before. Maybe someone's helped you do that in tech support before. But the other thing you do is you want to check your graphics card. That was the number one thing, right? If you're having issues in SolidWorks, the number one thing you want to do is go to Help, SolidWorks RX. And when RX opens, you can go to Diagnostics, and the very first section is about your graphics card. SolidWorks needs a pretty specific graphics card to run correctly. It will run on other cards. It will work on other sorts of cards, but for the most part, you need a capable NVIDIA graphics card to be able to run SolidWorks correctly at a high performance level. So let's say you've already checked those things, right? You've already kind of run into some problems. You've already checked your graphics card. And for everybody here, that's something, again, I would highly suggest you do is open SolidWorks, go to Help, SolidWorks RX, and check and see what it says about your graphics card. You can even dig into the certification page, and this will help you download the right driver. You can tell it what year you're running, what system you have, what specific model, and then what graphics card you have. And then you can double check from there and end up getting the right driver for your particular machine. Now, let's say you've already done that, right? You've already done all those things. Well, the very next thing I would do is dig into the BIOS. And again, let me know, has anybody here ever looked at the BIOS for your machine? This is like the BIOS is what's running under the operating system. It opens and launches even before your computer boots up. So when your machine is booting up, on every machine it's different, but like here I'll Google, let's Google this. How do I get to the BIOS on a Dell, right? So on a Dell, it says you would repeatedly press F2 as soon as you power on the computer. So I would just like keep tapping F2 on my computer while it's booting up, and then the BIOS will open. And the BIOS will look something like this. You can't even take screenshots. So I took pictures, right? Like digital pictures of what the BIOS looks like. But the BIOS is all pretty in-depth options about your machine that you can configure before it even opens. And as a SolidWorks user, you want to think about these a little bit because they can actually affect your performance in SolidWorks. So if I open the BIOS on a Dell, this is what it would look like. On a Lenovo, it will look a little different. On an HP, it'll look a little different, but they're all basically the same idea. And the first one I would check under performance is this one called Intel Speed Step. If this is on, if you leave Intel Speed Step on, your machine can actually dial back processor power. Your machine can actually pull back the speed and pull back the power if you're in a lower power state. If you have a battery, if you're a thing I ran into a couple times is if your power supply for your laptop is going bad, it can actually dial back the power if you have this on. So if you've ever seen a performance issue in SolidWorks, it's possible that Intel Speed Step is on and it's actually slowing down your processor. So that's something I would check into, right? Open your BIOS, check and see if Intel Speed Step is turned on. The whole point of this option is to save power. They're trying to conserve power, conserve energy, which makes sense, right? That's fine, but you don't want it to slow down your SolidWorks. Your second option, this is something else I'll call out here. It would be under video, and it's called switchable graphics, or Lenovo calls it discrete or hybrid graphics. Same thing. A lot of laptops, like I'm running a Dell laptop here, a lot of laptops will actually ship with two graphics cards. They'll have two cards inside of the machine. They'll have a small integrated low power card, and then they'll have a high end NVIDIA card like I have on this machine. And if this is on, if switchable graphics is turned on, the machine will actually try to switch between those two cards to save power. And the point of that again is like, hey, if you're not doing something that's graphics heavy, the machine can try and use the lower card to conserve power and conserve battery. Well, SolidWorks doesn't like that switching. SolidWorks can end up crashing and can end up having a lot of problems when your machine is trying to switch. So I usually turn this off. This is something I would just go in and disable because I want to use the big card all the time. I want to make sure it's using the NVIDIA card at all times. And in fact, even on my desktop here, let's jump all the way out to my desktop. I'll go to just more options here, and then we'll open up the NVIDIA control panel. And maybe this is something that you've seen on your machine. If you have an NVIDIA card, it should already be installed there by default. Just waiting for that to open. So inside of the NVIDIA control panel, under Manage 3D settings, you can actually pick, right? I'm going to zoom in so we can see what this says. You can pick your preferred graphics processor. Should I use the high-end card or should I use the integrated graphics card? This is really important for SolidWorks, right? You want to be using this high-performance card when you're running SolidWorks. You don't want to be having your machine try and use that integrated graphics. I'm scribbling all over the screen, but you want to be able to use that high-end card at all times, right? If you have that. Let me know in the chat if you see that on your machine, if that's something that you have run into before. Cool. All right, the third one's kind of cool. This is like a little bonus, but there's another one called USB Power Share. And if you enable this, it means that you can put your laptop in your bag, and even when your laptop is off, your USB ports will be live. They'll have power. So it actually kind of turns your laptop into a giant battery pack. It's like you have a really big battery in your laptop, and a lot of people don't even ever use the battery, right? They just plug in all the time. If you have your laptop like in your bag and you turn this on, well, now you can charge your phone and charge like anything else, right, with your laptop, which is pretty cool. But you have to enable this option, enable USB power share, which is kind of cool. Okay, all right, stuff. Some other really interesting performance issue kind of related with SolidWorks. Why is my SolidWorks so slow, right? This is like, I always get back to here, and you think like if you're working in a big assembly, opening up something larger, let's open up like a larger assembly. So I'm going to go to File, Open. I haven't opened this in a while, so let's dig a little bit here. And I'll find my miter saw. I have a really cool miter saw data set here. And this, like anything else, right, is just an SLD ASM, a SolidWorks assembly miter saw. Let's get this open. 300 plus parts in this saw. Looks pretty good. Maybe you've seen this before where a larger assembly takes a little bit longer to open. Cool. Right now it's creating a bunch of hardware for me. Maybe a great time to have another sip of coffee. All right, so we're going to get that open. And while that's opening, I'm just kind of using it as an example to say, like, sometimes you might experience slowness in SolidWorks. Sometimes you might experience slowdowns. And we we just went through a lot of tips and tricks for, let me close those mirror graphics. We just went through a lot of tips and tricks for the BIOS, right? Like some things you can do in the BIOS to make SolidWorks faster. But there's other things you can do as well. And this is actually important if, like, maybe you're running a machine that's not cut out for SolidWorks. Maybe it's not a top tier performance machine, right? Maybe when I don't know if some of you are in college or not, or in school, but when I was in school, I had a crappy laptop. It was not great. It was not a good, it was not a good laptop. I have a better one now, but when I was younger, I did not. And there's things you can do even in your memory to try and make run SolidWorks a little faster. So let's get to the desktop, and I'll show you what I mean here. So I'm going to get to my desktop, and on the desktop, I right click kind of in my task pane here, and I find Task Manager. Task Manager opens, and you have probably seen Task Manager before, where you can go through performance and see how your machine is doing from a CPU, memory, and so on, right? If you click memory, memory is your RAM. How much RAM do you have, right? I have 32 gigs of RAM on this machine. You might have less, you might have more, but this is trying to tell you how much RAM you're using and how much is free. And I can kind of hover over these fields here. I see, all right, I'm only using 21 gigs of 32 gigs, so I should have a whole bunch. But this little chart, I'm going to zoom in so we can see this. It's saying I'm only using 21 of 32, right? This little chart is misleading. And this is another space where you can make SolidWorks faster if you understand what's going on here. So with this, I can get an idea if I kind of look down here at what's going on. It's like, okay, I got in use, I got standby, and I have free. This is telling me I only have 1,300 megs of free RAM left. And it's like, oh, that's actually a lot less than I thought. If you hit these three dots, you can open up Resource Monitor. Resource Monitor is like a deeper dive into what's going on with your system. And I'm on the memory tab. You have all those same tabs at the top, but I'm on memory. And there is a bunch of columns here, but I get that same graph. In use RAM, standby RAM, and free. So standby is something called committed memory. And if I sort by this column, I can see kind of if I hover over what it says the amount of virtual memory reserved by the operating system for the process in kilobytes. So that means like every time you open a new program, every time I open SolidWorks, every time I open my browser, the operating system is committing another chunk of RAM, even if it's not using it. So suddenly you get into a space where you're like, I'm out of RAM, I'm out of memory. I didn't think I was because this chart didn't tell me. This chart's telling me I'm only using 21 of 32. But if I look a little closer, I'm actually basically out of RAM here. I don't have very much left at all. So there's things you can do to fix this. You can just reboot your machine. You can certainly do that, right? If you reboot your machine, it will clear out all of your virtual memory and bring that back. But there's even, I'll get back to the PowerPoint here. There's even a really cool tool called RAM Map. And RAM Map is right from Microsoft. This tool here, RAM Map, is right from Microsoft. I don't have it installed here, but if we Google that, I'll show you all what that looks like. It's right from Microsoft, so it's not like shady software. It's like directly from Microsoft. This lets you see specifically what's going on with your RAM, and it even has the ability to purge it. So you can have RAM Map clear your virtual memory while it's open, which is pretty cool. It's one of the really cool functions. So I'll share that in the chat too, that you could take a look at. And I would actually suggest like look through the other tools that Microsoft has, right? These are free tools directly from Microsoft that you can download and learn about, and they're just tools that are going to help you be a better computer user, right? A better someone who's more well versed in keeping your system running really well. And virtual memory is something. If someone would call into tech support, they'd say, "Hey, I have 64 gigs of RAM. There's no way I'm out of memory." But then we would check and see, like, yeah, but your standby is using up most of it. And usually that's because you haven't rebooted in a couple days. I'm really bad about rebooting. I don't reboot my machine. I reboot my machine only when I like absolutely have to. And eventually you run out of free memory. Eventually you run into a space where SolidWorks doesn't have the memory it needs to continue running, and maybe you get a crash like I saw before, right? And I am totally guilty of that. I do that all the time. All right, this one is really cool as well. Let's get back to SolidWorks. All right, like let's say I've done all that stuff. I checked my graphics card. I checked my BIOS. I checked my virtual memory. SolidWorks is still slow, or I'm still seeing issues. What are some tools in SolidWorks that you can use as a SolidWorks user to make everything run better and learn a little bit more about your data? Let's get back to SolidWorks, and I'll maximize my window here. And if I have SolidWorks open and I have this assembly open, maybe as a designer, you've put a lot of parts together and you're starting to see some slowdowns. You're starting to see some issues with your assembly. And you're like, well, okay, what are some tools here that I can use to dig into that? In your assembly, if you go to evaluate, look for assembly visualization. Assembly visualization is in every license of SolidWorks. Everybody has this. And if I open that, it will basically organize your tree and color code your components based on your choosing, based on topics of your choosing. So maybe I want to sort the tree by mass. What's my heaviest part? Well, the motor is 4,000 grams, right? So now I can see right away what is the heaviest part, and it's even color coding it so I can see it. What's the second heaviest part? That base. What's the third heaviest part? The table. That's really cool. But I want to look at performance issues. I want to look at what is making my assembly slow. This third or fourth button in here is performance analysis. If I turn that on, it just added 3 columns here. It added total graphics triangles, SW open time, and SW rebuild time. And if I'm looking at those, I can now learn a lot of information about this assembly and maybe understand some of the things that are making it run slowly. Let's sort by this one. Let's sort by total graphics triangles. Now I know that, okay, this base from a graphics perspective is the heaviest part in my assembly. Why do we think that is? Any guesses why this base is the heaviest, has the most triangles, and is the most graphic heavy? Let's see. Any guesses? If not, I'll just tell you. But all right, so let's do a really cool trick here too. I'm gonna right click on this part on this base, and I'm gonna hit component preview window. It opens up the part in this little extra window here that I can zoom in and out, mess with, and I don't have to leave the assembly. So that's really cool. The reason that that part is the heaviest is underneath, there has a lot of extra faces. And then on top, it has this sketch text with all of these edges, all of these new extrusions. Those sorts of things add a lot of weight. They add a lot of graphics weight to an assembly. So if you open up something on your end and you're seeing like SolidWorks, I'm going to hit exit preview here. SolidWorks maybe is like stuttering, like you open it and it's kind of like choppy. It's getting a little choppy. You can use assembly visualization to figure out, is it the whole assembly, or is it maybe just one part that's causing all of those problems? So now maybe for me, I know like, okay, I should go in and make a simplified version of this base where maybe just the sketch text is suppressed, or maybe some of these fillets don't need to always be there. We could suppress those and make a simplified version. But the point is, this tool helps you learn that. This tool helps you see that real time. I also get SW open time and SW rebuild time. So here, if I sort by open time, it's also telling me that that base is the part that's taking the longest to open. Like relatively, it's taking like, 4 or 5 times longer to open than the next closest part, which still like less than a second. It's still opening in less than a second, but it's taking a long time. And the reason for that, again, is probably it having to recalculate all of those graphics triangles on the way open. But in other cases, this column is cool too, because maybe getting back to references, what we talked about before, the references, maybe it's pulling the wrong version of the file, and this reference is a file that's sitting on a server somewhere else. Maybe you accidentally saved it or opened it from a different folder. Well, this again is something that can really help you understand what part is causing the problem and just lets you learn a little bit more. Okay. Some other tips here. We talked about SolidWorks RX quite a bit, and this is a tip for every single SolidWorks user, that when you have SolidWorks open, SolidWorks RX open, I did help and then RX. One of the things it tells you here is, when was the last time you rebooted? And I last rebooted 6 hours ago. I did have to reboot this morning. I rebooted earlier today for me. But this is a good tip for you, that even if you do that, right, sometimes RX will say you haven't rebooted in 2 or 3 or 4 days. Well, the reason for that is when you shut down, when you do Windows shut down, it doesn't actually shut down your machine. It puts it into like a partial shutdown, but it saves a lot of the data. If you hold shift when you're shutting down, it's a stronger shutdown. It will actually purge all the data and refresh your machine. So give that a try. I bet if you do a shift when you're shutting down and reboot your machine, your computer is going to run a little better, and SolidWorks, I hope, will run better for everybody as well. Let's check out a quick sheet metal question. That's what's cool about this presentation, is we jump around a lot. So now we'll take a look at a quick sheet metal tip. And let me know in the chat, of anybody here, if you've used sheet metal before. But I actually had this part open a little bit ago. And the question from a customer is, hey, I have a really simple sheet metal part. And if you've ever modeled sheet metal before, it's pretty cool because you can model the part, and then with SolidWorks sheet metal, you can flatten it. And then I know, okay, this is the part that I'm going to have to first cut out of metal. This is like my sheet metal part, and then I get to fold it up, and those are the bends. But here's the problem. Maybe you're modeling a sheet metal part and you need a cut or a some sort of feature to go across the bend region. But when you flatten it, it ends up being like this oval shape, right? Because it's crossing that bend, it's not a perfect circle. Well, SolidWorks lets you do something really cool called fold and unfold. So with the sheet metal part open, I can, with this part already kind of in its folded up state, I can unfold. This is my fixed face, and this is the bend I'm going to unfold. I can unfold it. I can then do a cut here. So I'll just like sketch on this face. This is my process for sketching. Maybe some of you do something similar where I pick the face, press the sketch button, and then auto orient my view. I do that every time. I hit S for shortcut. I'll grab a circle, and we'll just put a circle across this bend. It really doesn't matter where it is, right? And I'll do S for a shortcut, and I'll grab smart dimension, and we'll put a smart dimension on here of maybe 1.5 inches. I want to lock this down, so we'll put a dimension from the top as well. You want to fully define every time, so maybe I'll just do 6 inches from the top. Oh, I think that was a little too far. 60, not 60, 6 inches. There we go. All right, so that looks better. And then I will take that and do a features extruded cut. And because it's sheet metal, I can link to thickness. This means that no matter how thick this part gets, the sheet metal cut will always go all the way through, which is cool. We can link to thickness of the sheet metal part, and I'll hit green check. The cool thing now is because this is sheet metal, I can go back to sheet metal and just fold it back up. I'm going to pick this as my fixed face, and then fold this bend back up, and then hit green check. The difference here is if you look at these two holes, you don't end up with this like elongated hole. You get a true circle that even if I flatten the part, will show as a circle and still shows as a circle when you're folding up. So this feels like a weird example, but if you've ever used sheet metal or you're ever trying to do any sheet metal design, that unfold and fold function is really powerful. And I'll show you like one other tip. Let me know, has anybody here done any sheet metal before? But even if I took, we can stay in this part. It really doesn't matter. But I'll sketch on this top plane. I press the plane, begin the sketch, and we'll just put a box out here in space. It really doesn't matter. Doesn't matter what it is. And that box, let's put some dimensions on it, will be a 12-inch box. And I'll grab this edge, hold control, and grab this edge, and let's make them equal. Those two edges are now equal, right? So that's just a box kind of floating in space. And we'll turn that into a boss extrude that is also 12 inches high. Not linked to thickness. This should go 12 inches high. End up with just like a big box here in space, right? Well, sheet metal has something called convert to sheet metal. Convert to sheet metal lets you pick a part like this, like a box that we just made, and say like, this is my fixed face, and then this is an edge, this is an edge, this is an edge, and this is an edge. And I'll hit green check, and we'll see kind of what that does. Now it took that box I made and converted it to a sheet metal box that you could flatten. I gotta get out of there. That you could flatten, and ultimately you can kind of see what it did. It even ripped that edge to make that into an actual sheet metal file, which is really awesome, right? So that convert to sheet metal is really powerful because it kind of lets you take a a sheet metal body and wrap it around an existing body. Let me see if I can flatten just this one. Let's see, maybe I don't want these guys. I don't know if I can flatten just that one. I was hoping I could flatten just this one body, but I think I have to do it in a separate body for that to happen. Let's redo that in one more part file, and this will probably be our last tip here. Part, we'll do front plane, sketch, same thing here. We'll just do a square. And in this square, I'm going to hit S for shortcut, grab my smart dimension tool here, 12, and then I'm going to hit exit sketch, and we'll just go right to features, extruded boss. This is the sketch I'm going to extrude. And same thing as before, we'll just extrude this by about 12. Green check. All right, there we go. So same command as before. If I do sheet metal, convert to sheet metal, you're kind of picking your fixed face. So this is like my fixed top face. And then it asks what bends you want to fold. So I'll fold that one and fold that one. Those are being folded down. And then we'll also fold that one, and we'll also fold that one. And then we'll hit green check. All right, so what I was trying to show you before is now that we have this sheet metal body like wrapped around itself, we can do flatten and see what that would look like in real time or real space. So that works for sheet metal, but you could also imagine that as like fabric or cardboard as well. So there's other functions, there's other uses for that. But if you've ever wanted to model sheet metal, you don't actually have to always model sheet metal, right? You could start with what's just the box, right? What is the box shape that I'm trying to get to? And then have convert to sheet metal, wrap a sheet metal part around that. So that's pretty cool too. All right, so Edward, we're kind of right at the hour here. I only had like one more tip that I wanted to cover after that. But maybe I'll pause there. Edward, what do you think? Any questions? Anything anybody else wanted to ask?
Maybe from my point of view, I would like to ask, what if you are taking your certification exams and all of a sudden your Solidworks crash? You know, it can be frustrating and the clock is winding down. Like, if you
Yeah.
have any tip for that, it would be very helpful.
Yeah, that's such a good question. And that gets back to like so much of what we were talking about before, right? Like before you do certifications, check SolidWorks RX. Make sure that your graphics card driver is good. Make sure that you have rebooted and you've cleared out your memory that we talked about. Check those BIOS settings, right? Check Windows speed step, like do all of that, because yeah, you don't want SolidWorks to crash in the middle of a certification. That's a really good point. But one thing I would say is when you're doing the certifications, save and save often, right? Like you have a part open, you whatever it is, whatever certification part you're working on, save it often. File, save as, save it off somewhere. So even if SolidWorks crashes, all save frequently. Get used to Control S. Control S is save, right? Do that all the time while you're taking the exam. So even if SolidWorks crashes really quickly, as you saw with me before, even if you have a crash, if the part is saved, you can reboot SolidWorks, get the part back open, and hopefully you don't lose very much time.
Okay.
Yeah.
Okay, another quick question. With SolidWorks 2025 now, we have an AI built-in tool. So actually, I'm not familiar with that. If you have any tips on how you can leverage that tool, I think if you can share with us, it will be very helpful.
Yeah, it's a good question too. I also am not too familiar with it yet. There's a few new AI things coming. But the one I know that we have right now is the command predictor. There's the command predictor is supposed to kind of predict what command you're going to use next. Quite honestly, Edward, I haven't spent any time with it either, but on Monday of this week, I just saw a whole new presentation about everything we're doing with AI, everything meaning that SolidWorks is doing with AI. So very soon, I hope in the next like month, I'll be able to take that presentation and show it to you and show it to really all the user groups. So why don't we agree that on a future meeting, I'll come back and show everybody here what's new with AI as a whole.
Okay. Thank you for that.
Yeah. Okay. Well, everybody, I could go on forever. I have, more tips and more stuff. For the sake of time, I think we'll stop there. But if there's ever any questions you have, I'm going to drop my email here in the chat. That's my email.
I think
Yeah, go
there's
ahead,
a
Edward.
I think there's a quiz that I sent you an email that we should have a quiz at the end of the presentation, and then the selected winner will have that $25 gift card. So
Yep,
I'm really looking forward for that at the end of the presentation.
for sure. Yep. Let's do the quiz with, have you ever used Kahoot before, Edward?
Yeah, I've seen it actually in other Solidworks user group. Yes.
Okay. Yeah, let's do that real quick. Um, I'm just opening it on my other screen here. Okay. Okay, cool. Well, Edward, thanks for having me on today. I appreciate it. Let's run this quiz, okay? So, everybody, on your end, you want to go to kahoot.it and you're going to type in this pin here, 390-308. I'll wait for everybody here. If you have a phone too, you can do it on your phone really easily. I'll give everybody a minute here to get signed in, okay? You're going to go to kahoot.it and then type in 590-308. All right, looking pretty good. Give everybody one more moment. Edward, have you seen this quiz before, a SolidWorks pub quiz?
Yeah, I've seen it before. Actually, you have done a presentation like this with London Solidworks user group. I remember.
Oh, cool. Nice.
Yeah.
All right, so maybe everybody's already seen this one and it'll be review. Let's see. Okay. All right, let's get started. And as we get moving here, other people can still join. Even while the quiz is going on, you can go to kahoot.it and do 590-308. But we're going to start the quiz. All right. So the way this is going to work, you're going to get to pick the answer on your end, and I'll show a leaderboard here on my end. When editing a sketch, what does the A key do? If you're in SolidWorks and you're editing a sketch, what does the A key do? All right. Transitions from an arc to a line or vice versa. That's the one that got the most answers there, and that was correct. And Polite Sable is at the top of the leaderboard here. So what you'll see is it's not only getting the right answer, but it's also doing it quickly, whoever does it first. What does the G key do in SolidWorks? What does the G key do? You can go test this, right? If you have SolidWorks open, press G. Three, two, one. All right. It is magnifying glass. So you got some good answers there, but we would accept magnifying glass or magnify glass or magnifier. But we got two people that did magnifying glass, which is great. Funky Narwhal is now at the top of the leaderboard. What tool allows you to save any customization to the SOLIDWORKS user interface and settings? So those settings we talked about before, there's a tool that lets you save that off. Type your answer. What do you think the name of that tool is? If you want to move your settings from one machine to another. What do we think? I see copy settings. Yeah, so we would accept copy settings wizard, copy settings whiz, or copy settings. I don't think anybody got that. So I don't see any right answers on that one. So Funky Narwhal still at the top of the leaderboard here. What does FeatureWorks do? Have you ever used FeatureWorks before? What does FeatureWorks do? This guy looks really confused. He's not sure. So what does FeatureWorks do? Multiple choice. So most people says it recreates an imported model using SolidWorks features, which is the right answer. We had 5 people get that. And now Shimmering Armadillo is moving up the leaderboard here, doing an awesome job. Is it possible? It is possible to snap an entity to a sketch without creating a relation. Have you snapped an entity to something else without it creating an automatic relation before? True or false? You can guess here too if you're not sure. All right. So most people said true, and still some 4 people said false, but true is the right answer there. It is possible to do that for sure. Shimmering Armadillo is pulling away here. We got to get someone to move up this leaderboard. I'm not sure who Shimmering Armadillo is, but wherever they are, maybe it's Edward. Edward could be cheating. I'm not sure. I'm just kidding, Edward. You can only use 3D markup in SolidWorks if you have a touch screen. This is a weird one, but uh, you can just guess here. This is kind of a weird one, but 3D markup is cool because you can do these kind of like sketches on screen, but that's false. Anybody can do it. You can use your mouse, you can use a touch screen, if you can use a stylus, but 3D markup, if you look for that command, is a cool way to save notes on a part. Shimmering Armadillo. Up, that gap is smaller though. Polite Sables is definitely moving up. What does F9 do in SolidWorks? You press F9. What does it do? You can test this. All right. 7 people got this right. It hide and shows the feature manager. Awesome. That's F, all those F keys. If you run through those, they usually all do something. What is the maximum number of recent documents you can show? I hit R a whole bunch of times today. What do you think the maximum number of documents you can have in that list is? 3, 2, 1. It's 100. You can put 100 files in that list, which is pretty crazy. You probably would start forgetting what they are, but you can put 100 in there if you have them. Which 3 keys give you the maximum graphics area? We just talked about shortcut keys. Pressing this certain combination hides a whole bunch of stuff. What do you think it is? 4, 3, 2, 1. All right. F9, F10, F11. Hide the tree, hide the command manager, and hide the task pane. All of those will get you all that graphic space. So try that on your machine. F9, F10, F11. Shimmering Armadillo is there, but determined emu is coming not too far behind. All toolbox files are made with true helical threads, but not in the default config. If you open a toolbox bolt, does it have helical threads on it? Do you see that on every component? True or false? That's false. Not every part has that. That would be crazy, right? We don't want all those helical threads on every single file. So 6 people got that one right. Let's see. Shimmering Armadillo. Determined Emu's coming though. This gap looks like it's getting smaller. How many features, including sketches, are required for this model? We talked about sweeps before, right? How many features, including sketches, would you need to make this? What do you think? 10 people got that right. 10 people said 2, but it's actually 3 because you would need the plane, the circle sketch, and the sweep as well. All right, what version of SolidWorks saw the updated command manager that we know today? This is kind of a weird one, but that command manager, this is a shot of the first year that we had it, but that command manager that sits at the top, what do you think the first year was that came out? All right, 8 people got that. 8 people said 2010, but 2 people said the right one. It was actually 2008, which is the year I graduated college as well, 2008. Shimmering Armadillo still at the top of the leaderboard here. What version of SolidWorks saw the intro of weldments? When did we first see weldments in SolidWorks? 'All right. Okay. So 3 people got that. That was in 2004, which is awesome. All right. Couple more. What is the fastest way to model a real 3D thread? Fastest way. How do you think you can do this really quick with actual 3D threads? 11 people got that right. Awesome. The thread command. Yeah, that's great. And who was SolidWorks CEO in 2015? That's a weird one, but we added this in here. SolidWorks CEO 2015. This is a little bit of SolidWorks history for you. John Palavasi was CEO. We know now he has moved up even to a higher role in Dassault Systems, but yeah, that was GP in 2015. All right, I think this is our last question here. Was this your favorite Swuggen meeting ever? Yes or no, or one of these other answers. So Edward, at the end here, I'm going to need you to get the winner's info and just email them to me, and we'll get that gift card out to them.
Okay. Thank you.
12 people. Oh, come on. Someone said no, but no idea, but Kirby is an awesome group leader. That's pretty funny. All right, Shimmering Armadillo is our winner. So whoever that is, Edward, we got to figure out who that is, but they can reach out to you and we'll make sure to get that gift card out to them.
Okay. Thank you.
Yeah. Edward, I've got to run at this point, but this has been awesome and I appreciate the time connecting with you all today.
I appreciate you also for dedicate your time also to share some of the tips and tricks to the Solidworks community. It's a pleasure to have you, and we look forward for the next meetings, especially for those you said the AI tools in Solidworks for the upcoming month. You have something that you can present to us, so we are really looking forward for that.
That
Also,
sounds good.